video, I will demonstrate how to find the maximum and minimum value of an objective function as given in Chapter 6, problem number 17 of the book's practice test. It gives us the objective function 2x minus y, and we have the constraints of x is greater than or equal to 0, y is greater than or equal to 0, and y is greater than or equal to negative 2x plus 8. So, the first step we have to do in order to solve this equation, or to solve this problem rather, is to graph the constraints. So, we look at the first one, x is greater than or equal to 0, which is fairly easy to plot. It's just the right of the origin on the x-axis, and y is greater than or equal to 0 is also easy because that is upward of the origin on the y-axis. Now the third constraint can actually be simplified. Y is greater than or equal to negative 2x plus 8. This can be divided by this can be divided by 2 actually, to y is greater than or equal to negative x plus 4. It's essentially the same equation. It's just we divided everything by 2. So we would graph it as the y intercept is at positive 4, and we're going to draw a negative slope. Through here. Okay, so now what we have to figure out is we have to figure out where the lines are intersecting each other. And from this we can see that the points that are intersecting is at 0, 4 on the y-axis, and it is also at 4, 0 on the x-axis. So this problem isn't done yet. We have to figure out what the maximum and minimum values are. So we have to plug these back into 2x minus y. When we do that, f(x) equals, we'll do the first equation, which will do the y-axis point first. That'll be 2, 0 minus 4. That's negative 4. And then the other one, f of x equals 2 times 4 minus 0, which is 8. Negative 4 is the minimum value, and 8 is the maximum value. And that is how you find the maximum minimum value of an objective function given some constraints.